Okay guys, so today's lesson is on single-step mole conversions. This is going to be the big foundation to a long period of time as far as the class goes. So this is important to make sure that you're attempting the examples tonight, and then we'll have lots of practice tomorrow. So let's get started. First things are some things that you just have to know. And so in order to the equalities to do these single-step equations. So they are all equivalent to a mole. So all three of them involve 1 mole. And it's important that you understand that they are all 1 mole equalities. And so just like we can have other units that are equal to several things. For example, 36 inches is equal to 3 feet. It's also equal to 1 yard. And so you can have things be equal to multiple other measurements, which is what's going on here with the mole. 2 of these you already know. And so they are the fact that a mole is equal to 6.02 times 10 to the 23 particles. The other one is that 1 mole is equal to the molar mass, which is expressed in grams. And the last is the 1 mole is equal to 22.4 liters of a gas. This only applies to gases. You cannot do this 22.4 liter with liquids or solids, only gases. And not only that, but it must be specified. The gas must be specified to be at STP. So let's define STP. STP is equal to standard temperature and pressure. Gases are very sensitive to changes in temperature and pressure. Right? If you change the temperature, the volume will increase or decrease depending on which way you're changing the temperature. And so this volume is very sensitive to that. And so we standardize it as 0 degrees Celsius as our standard temperature, and our standard pressure is 1 atmosphere, which is the atmospheric pressure at sea level. And so these are the 3 equalities that we're going to be using. You need to memorize these equalities, put them in your head, and just know them. They're very, very important. They're critically important to your future for the next several months. Okay. All right. So let's continue. We're just going to do some 4 examples. I'll walk you through them, and hopefully you will learn how to work these pretty easily. So the first example is this one. How many atoms of copper are in 1.65 moles of copper? I've gone ahead and given you the correct equality to work this problem, which is the mole to particle equality, because we're looking for atoms, and an atom is a particle. An atom is not a mass and it's not a volume, it's a particle. And so we're going to use atom in place of particle here. And we have moles is the other side of the equation. So that's what we're looking for. So here's how you're going to do this. You're going to start out with what you have been given in the problem. You have been given in this problem 1.65 moles of copper. And so begin with that. Always write down your given first. 1.65 moles of copper. The abbreviation for moles is MOL. Put that over 1. I'm going to recommend you put over 1 to begin with. As you get more efficient and you understand this better, you don't have to put this over 1 anymore. But for now, for sure, do that. We're going to multiply by our fraction bar. Remember, we did this earlier in the year. Now we just need to take this equality and stick it in our fraction bar equality here. What goes in the top and what goes in the bottom? Well, looking at the previous step, we have moles in top. So we're going to put moles in bottom. And our equality says that it is 1 mole. And then we're going to put the other half of the equality on the top, which is this. 6.02 times 10 to the 23rd atoms of copper. If you look at the units, you're going to have the mole, cancel the mole, which is what we want to happen. And the unit that remains is atom, which is what we're asked for. How many atoms? Punch that into your calculator, and you are going to get 9.93 times 10 to the 23rd atoms of copper, which is what we were looking for. Now I've got 3 significant digits here because my original number had 3 significant digits. Whenever you're doing mole equalities or mole conversions, always use that starting number as your significant digit limiter, if you will. Okay? All right, let's move on to the next one. How much would 2.38 moles of water weigh? Now, in this case, and I've gone ahead and given you the equality in the first one and this one. I've given you the equality that you're going to need, but you're going to have to be able to decipher that. In the questions, on the quizzes and tests and labs, you've got to figure out what you need to use. So which of the 3 you need to use. It's pretty easy. I mean, you've got moles and you've got weight, and weight is grams, right, or mass. And so you're going to need to use the equality that has the mole and mass in it. So that's how you figure that out. Now, we're going to need to know the molar mass, in this case, of water. So we need to go to our periodic table and pull that out. And so water is H and O, H2O. And so looking at hydrogen, 1.008. Looking at oxygen, 15.999. I will say this. I just have a bunch of the numbers in my head just from years of using them. And I learned hydrogen not as 1.008 but as 1.0079. And so I'm going to use 1.0079. If you use 1.008, you'll get a very, very slightly different number as your answer, and that is okay. It's not going to be wrong. So don't worry about it. If it's going to be like in the 4th decimal place, 3rd, 4th decimal place. We'll be slightly off. That's okay. Don't worry about that. All right, so let's come back over here. So we have 2 hydrogens. So 2 times 1.0079, again, that's what I have. You can use 1.08 here. And we're going to add to that 1 oxygen, 15.999. When you add these things together, you're going to get 18.0148. Okay, and then let's just set it up. We're going to start with what we know. We know we have 2.38 moles of water. That is what is given to us in the problem, 2.38 moles of water. It is very important as we work these that you include your units. And I'll point that out in a second here, why that's important, but let's just continue for right now. Now, what unit do we put on the bottom? Do we put the mole on bottom or the molar mass on bottom? We're going to put the mole on bottom because it's going to cancel. So 1 mole of water, and we're going to put the mass that we just figured out, the molar mass of water, 18.0148 grams of water on top. And that's our setup. So then we just do the math. If you take a look at this step right here, this is molar mass, which is what it says up here. But even simpler, when we did the molar mass a few units ago, we wrote it like this. We wrote so many grams per mole. Grams per mole is molar mass. Molar mass is a conversion unit. All right, so punch this in your calculator, 2.38 times 18.0148, and you are going to get as an answer 42.9 grams of water. Again, using the starting 3 significant digits as your limiter, 3 significant digits in our answer. Now, just talking about units. If you didn't write your units down here, you just did 2.38. How would you know what goes on the bottom? There's no unit here to tell you what unit goes on bottom. You might accidentally put 18.0148 on bottom. And so make sure that you're writing down your units in these mole conversions, particularly early as you begin to learn it. As you get more experience and you can almost visualize these problems in your head, then it may not be so critical to write down the units in some of the simple problems, and the more complex ones you probably should always do it anyway. So just make sure you're writing down your complete units. All right, 3rd example. 7.83 liters of oxygen gas would contain how many moles of oxygen? Okay, so you've seen a couple of examples. Here's what I want you to do. I want you to pause the video. I want you to try and work this. I've given you the equality to use. Start out with what you have, set it up, get the answer, and then unpause, and I'll work it for you. So pause now. Okay, and so hopefully you've solved the problem. You did what I asked you to do. We're going to start out with what we have here, 7.83 liters of oxygen. 7.83 liters of oxygen. And oxygen is O2. We'll talk about that in a little bit. Put that over 1. And then we're going to use our equality here. And which one of these will go on the bottom? Since we have liters on top, we'll put the liters on bottom. 22.4 liters of oxygen. And we're going to put the 1 mole of oxygen on the top. Plug it into your calculator, and you should get 0.350 moles of oxygen. Okay, so hopefully you got that as an answer when you practice it. If not, it's okay. Make mistakes. We just get better. Let's do our last one. How many moles of NaCl are in 73.48 grams of NaCl? So once again, I want you to pause the video, work that. This time I'm not giving you the equality. Which of the 3 equalities are you going to use? You need to figure that out. So pause it, work it, and then unpause and check it. All right, so let's go. And so what we're going to use here is the 1 mole equals molar mass equality, because we're looking for grams, or we have grams, and that's mass. So we're going to need the mass of NaCl. If we go to our periodic table and look up NaCl, Na right here is a 22.990. Cl is 35.453. And so we're going to have a 22.990 plus 35.453. You add those two together, just one of each. Add those two together and you get 58.443 as your molar mass. All right, plug those in. 73.48 grams NaCl. That's what you're going to start with. Put it over 1. Do your multiply by your fraction bar. We're going to throw our conversion equality in there. We have grams on top, so we'll put grams on bottom. So that's going to be the 58.443. 58.443 grams NaCl. And we'll put the 1 mole on top. Looking at your units, your grams will cancel your grams, leaving you the moles, which is what you want. Plug it in your calculator. 73.48 divided by, since it's on bottom, divided by 58.443. And you are going to get off of that 1.257 moles NaCl. Okay? All right, so hopefully you're picking up on how these work, and we will see you tomorrow.